In this video, we're going to continue our discussion of absolute value functions. A vertical stretch is a type of transformation that makes a graph of the parent function taller or narrower, as compared to a vertical shrink is a type of transformation that makes the graph of the parent function shorter and wider. The next type of transformation we're going to talk about is a reflection. A reflection is a mirror image of the parent function with respect to some line. Now, to briefly review the steps to graph an absolute value function. First, you're going to locate and graph the vertex. Then you're going to graph the axis of symmetry. Next, you're going to use the slope to graph the right side of the graph. And finally, you'll reflect the graph to the left side of the axis of symmetry using corresponding points. And again, to review our general formula is y equals a times the absolute value of x minus h plus k. The a stands for the slope of the right side of the graph. The h is the x-coordinate, but you have to remember to switch the sign. And finally, the k is the y-coordinate, but you have to remember to keep the sign. To graph the absolute value function, first we're going to rewrite our function in the standard form. So it's y equals 1/4 times x. Since there's nothing else in the absolute value, it becomes minus 0. And since there's nothing else outside the absolute value, it becomes plus 0. So our vertex is the opposite of the h value, which is 0, comma, the k value. So I can plot my point at 0, 0, and draw in my axis of symmetry. Next, we're going to use the slope to graph the right side. So our slope in this equation is the 1/4 because it's outside the absolute value. So I can graph my next point. So I'm going to go up 1 and over 4 to the right and draw in my line. Finally, you're going to reflect this to graph the corresponding point. So since I had to move 4 units to the axis of symmetry, I'm going to move 4 units to the other side and draw in the other side of the graph. Pause the video and try the next one on your own. First, you're going to rewrite the equation in the standard form. So it becomes y equals -3 absolute value of x. There's nothing else inside the absolute value sign. It becomes minus 0 plus, and there's nothing else outside. So it becomes plus 0. Now the vertex is the opposite of the h value, so it's 0, comma, the k value, which is 0. So I can plot the vertex and draw in the axis of symmetry. Then you'll use the slope of the right side to graph the equation. So our slope here is -3, which is really -3/1. So on the right side, I'm going to move down 3 and over 1 and draw in the right side of the absolute value function. Lastly, I'm going to reflect this point over the axis of symmetry and draw in the left side. In the next example, you're going to first rewrite the equation in standard form. So it's y equals 1/3 absolute value of x plus 2. And since there's nothing outside the absolute value, it becomes plus 0. Now the vertex will be at the opposite of the h value. So since it's positive 2, it becomes -2, comma, the k value, which is 0. So I can plot the point. Then I can draw in the axis of symmetry. Next, I'll use the slope of the right side. So in this case, the slope of the right side is 1 over 3. Go up 1 and over 3 and draw in the right side of the function. Lastly, you're going to reflect this point onto the other side to draw in the left side of the function. Pause the video and try the next one on your own. First, let's rewrite the equation in standard form. So it becomes y equals -4 absolute value of x. Since there's nothing else inside the absolute value, it's minus 0 plus 2. Now the vertex is the opposite of the h value, so it's 0, comma, the k value, which is 2. So I can plot my vertex and draw in the axis of symmetry. Then I'll use the slope of the right side. So the slope of the right side in this case is -4, which I can rewrite as -4 over 1. So I'm going to go down 1, 2, 3, 4 over 1 and draw in the right side of my graph. Finally, I'm going to reflect this point to the other side and draw in the left side of the graph. In our last example, the equation is already written in our standard form. So I can start by determining that the vertex is the opposite of the h value, so -1 becomes +1, comma, the k value, which is -2. So I can plot my vertex at 1, -2. Then I can draw in my axis of symmetry. Next, I can determine from the equation that the slope of the right side is 2, which can be rewritten as 2 over 1. So I'm going to go up 2 and over 1 and draw in the line. Lastly, I'm going to reflect this point onto the other side and draw in the other side of the graph.